so this is our digital learning day. This is going to be our lesson on Vanguard problems learning day. Lesson on Vanguard problems. Okay, so let's look at your class page for starters. Okay, so if we go into My Crew and you look under your topics, we'll look under topics and you'll see Vanguard problems right here. Okay, so what I would like you to do is to go into that page. We'll click on Vanguard, and this sort of describes what we're going to be doing. Vanguard problems. I have a link, first of all. If we hit that, there's a list of hundreds of problems. And we're going to look at the first few, but let me get out of there and go back to this. This links to hundreds of Vanguard's problems. So Wikipedia gives a little history behind the Russian computer scientist Mikhail Vanguard, died in 1971. And I've got a couple of other links here. I really enjoyed both of these books. This book here, Mathematics, the Science of Patterns. The author is Keith Devlin. He discusses and explains many of the patterns found in mathematics. This book is down in our library. You might want to look at that. And we also have this one, which actually won the Pulitzer Prize. Doug Hofstadter discusses artificial intelligence and pattern recognition. He uses mathematics, Gödel, who's a mathematician, Escher is art, M.C. Escher, and then obviously Bach, music. He raps in an eternal golden braid, mathematics, art, and music, and discusses artificial intelligence, pattern recognition. A marvelous book, good summer reading if you're so inclined. Okay, so what do I want you to do? First of all, I want to look at a few puzzles and talk about how they're structured and how I want you to solve them. I've got the first four solutions here. Vanguard problem number 1, 2, 3, and 4. Empty, not empty, big, little, white, black, convex, concave. So if we go to the index and we select on problem number 1, what you'll see are 12 squares, 6 to the left, 6 to the right. And all the 6 on the left here, so this is our left side, well, they all have something in common. And the 6 on the right side all have something in common. And your task is to figure out the common characteristic between the ones on the left and the ones on the right. Well, this is rather trivial. As I mentioned, Vanguard problem 1, the left side is empty, and the right side is not empty, or it has something in it. So again, if we look at the picture, that's pretty clear. So left side empty, right side not empty. Let's look at problem number 2. You just click on the instructions here, pretty fun. Click on the right page. So think of this as a notebook. Click on the right page, and that flips the page. Hang on a second. Okay, so here we are again. Yes, click on the right page, this is the right page, to see the next Vanguard problem. So if I just click there, now we're Vanguard problem number 2, and you can see if you click on the left page, you go back to the previous one, back to the right page. Okay, problem number 2. What do these have in common? Well, I already gave you the solution. Here's the solution again. On the left, you see big things. On the right, you see little things. So here's the problem, big things, little things. So that's pretty clear, left and right. Okay, so left side, they're all big. And let's look at problem number 3. Hopefully you could look and say, everything over here on the left is white and everything on the right is black. And whether you call it white or black or hollow and filled, it's the same idea. You know, here's the test for Vanguard problems. If I give you a new square, okay, so here's a square, and I put this shape in here. Let's say I make some sort of weird polygonal shape, and I say that's my shape, which side does it go to? It should be pretty clear, aha, this has got to go over here to the left side, right, because it's empty. On the other hand, if I were to actually fill this in and say, what side does this go to now? You should look at it and go, let's see, will this move? No. Okay, so if I were to do that, now it has to go on the right side because it's been filled in. Okay, so that's sort of a good test to see whether you know the categories. Okay, let's look at number 4. Okay, so number 4, here's my solution. I said convex and concave, and now you're going, golly gee whiz. I understand empty and not empty. I understand big, little, white, and black. What do you mean by convex and concave? Here's the problem once again. We have got to decide what the ones on the left have in common and what the ones on the right have in common. And what you may notice is that everything on the right has sort of like a hollow to it. So there's a hollow here, sort of a little dip or a hollow there, and likewise here. Whereas on the left side, no hollows. These are as you go around, then I don't see any hollows. The boundary is sort of either straight or perhaps it's curved out. There's no curving in anywhere. Here's a nice way of thinking about concavity and convex. Suppose you had a rubber band. So this blue thing represents some rubber band. Let's make it a small rubber band. And I stretch it, and I put it around the outside of the figure. Okay, so if I bring this guy over here, and if I were to put it on this triangle, think about what the rubber band would look like. Well, the rubber band would go like this. It would go right along and touch all the edges of the figure. Okay, so that's a convex figure. On the other hand, if I were to take a rubber band and try to put it on here, well, what is the rubber band going to do? It's going to go, let's see, it's going to go tight here and then tight here, but it's going to go across that gap, tight, and then come across that gap. And you'll see these sort of hollow spots where the rubber band doesn't fit against the surface. That's a concave object. Okay, so all the ones on the right side here are concave. The rubber band would not touch all the edges. But everything on the left side are convex. A rubber band would touch the edge as it goes all the way around. Okay, so now here's your task. You're going to go and continue to work these problems. I would suggest do them in order. This is number 4, so there's number 5, number 6, number 7, and so forth. Okay, so you're going to go all the way through. If you want to jump around, you can go to the index. You know, here's problem 48. You go, golly gee whiz, maybe I don't want to try that one yet. Here's the index. Where's my index? Let me back up here. There, here's my index. Okay, so Bondard's problem, his original set went from 1 to 100. He thought, interestingly enough, that 1 was the simplest problem. He wrote these originally for computer recognition. If you had a computer that had some sort of video camera and some software that could recognize patterns, and a computer saw the 6 shapes on the left and the 6 shapes on the right, could the program discern what was going on between the ones on the left and the right? And he thought a pretty basic visual program could say, hey, these have nothing in them and these have something in them. At any rate, he thought number 1 was the simplest one. He thought number 100 was the hardest. He thought no computer program would ever be able to work this one. And yet, interestingly enough, for humans, I would think everybody would immediately say the ones on the left are the letter A and the ones on the right are the letter B, even though some of these look hardly B-ish. You see a B in all of those and you see an A in all of these. He thought computer programs could not do that. In fact, you know, nowadays, here we are 40 years later, 50 years later, you've seen these internet capture programs where you're supposed to write down the letters that you see to log into a website. That's because many, many computers cannot discern letter shapes or letter forms, and yet you can as a human. Okay, so here's your task. You are going to go and start to work these Vanguard problems, and I want you to write what you think are the solutions. They may not be correct, but give it your best shot. Let's see if this is your This is going to be a Google Doc that I will share with you. So you'll have that. I've got the first 4 done. So what I would like you to do is to go into here, go in, let me pull up my keyboard here. Okay, there's my keyboard. And I don't need 2 keyboards, Joe. There's my keyboard. Okay, so you're going to type in problem number 5. Problem number 5. My number is number. Keyboard would certainly be a whole lot better. Let's just say problem 5. Okay, and then you're going to type in what you think are the solutions. So something for the left, yes, and then a slash and no. So whatever you think the dichotomy is between the 2 categories, and then if you can tab over or just control over these Google Docs allow you to tab. There we are. And then you're going to write solved by whoever you are. Okay. Solved by. And then please put in your name so I know who came up with the solution. Okay. Okay, so that's the idea. Now, how many of these do I want you to do? I want you to spend 20 minutes on this, and you are going to work, not go to 100, but go all the way back to start with number 5, would make sense. Okay, and look at these and try to discern as best you can what the things on the left have in common and what the things on the right have in common. Some of them are difficult, some are easy. I would think this one might be easy, and if you see the point of the thing, then it might be even easier still. Okay, so don't get all curvy on me. Just look at the problems and decide the category for the left and the category for the right, and then just go and again click the page, and once again you see something here on the left and something on the right. Okay, so please work those, get those back to me. We'll have a submission deadline. You're going to put them into your web page. So let's see, my crew, and then this should be under assignment. So look under your assignments, and I don't have it here, but I'll include this as an assignment, and you're going to put it into my Dropbox, and I need to have 20 minutes worth of work, and I can tell what 20 minutes is. It may not be 20 problems, it may not be 10 problems. For some of the easy ones, it may be 30 problems. If you get a Vanguard problem that's a real stinker, just skip it, enter it into your Google Doc, but don't worry about solving them all in order. I would suggest you start with number 5 and work on. Okay, so any questions, please feel free to email me, and that will be the end of this little lesson.